so let's go ahead and get started. There's incredible interest in AI across the industry, and this is also, when we look at it, AI is really the defining technology that's shaping the next generation of computing, and frankly, it's AMD's largest and most strategic long-term growth opportunity. Now, in AI, we're focused on three key areas. First, it's delivering a broad portfolio of high-performance GPUs, CPUs, and adaptive computing solutions for AI training and inference, spanning across data center, edge, and intelligent endpoints. Second, it's developing an open and proven software platform to enable our AI hardware to be deployed broadly and easily. And third, it's really working with the industry, and it's expanding the deep and collaborative partnerships we have established to really enable the ecosystem to accelerate AI solutions at scale. Because in this space, there's no question that AI will be the key driver of silicon consumption for the foreseeable future. But the largest opportunity is in the data center. And over the last 6 months or so, the broad adoption of generative AI with large language models has really taken this growth to a different level. So people keep asking me, what is the opportunity, Lisa? What is the opportunity? What I'd like to say is, look, we are still very, very early in the life cycle of AI. I mean, there's so much opportunity for us. But when we try to size it, we think about the data center AI accelerator TAM growing from something like $30 billion this year, over 50% compound annual growth rate, to over $150 billion in 2027. And it may be higher, it may be lower. But what I can say for sure is it's going to be a lot, because there's just tremendous, tremendous demand. Now, AMD has been investing in the data center accelerator market for many, many years. And today, if you look at where we are, we power many of the fastest supercomputers in the world that are using AI to solve some of the world's biggest challenges. For example, at Oak Ridge National Labs, this is the #1 supercomputer in the world. It's the industry's first exascale supercomputer in Frontier. They're running large AI models on AMD Instinct GPUs to accelerate their cancer research. In Finland, the Lumi supercomputer uses AMD Instinct GPUs to power the largest Finnish large language models with 13 billion parameters. And we're also collaborating with researchers at the Allen Institute who are also using Lumi to create a state-of-the-art, fully open LLM with 70 billion parameters that will be used by the global scientific community. So let's just take a deeper look at how Lumi is using EPYC CPUs and Instinct accelerators for AI.
Cancer is one of the major burdens for human health. It takes a long time for the pathologist to go through one sample.
The aim of Combat AI is to build this decision support tool for pathologists to help them make the diagnosis. We show millions and millions of tissue samples taken from patients to this neural network. The more data you feed, the better the model becomes.
It takes a lot of compute to crunch that data and develop insights that we can use to advance humanity.
So the major challenges in analyzing these tissue images is, of course, a lot of this technical variation that arises from preparing these samples, like fixation and cutting and staining. And this, of course, poses challenges in training these neural networks. So with these AI-based decision support tools, we are able to provide pathologists with a tool for them to base the diagnosis on the data.
This supercomputer we built is going to help people to build more accurate and better models, get better outcomes.
We're impacting the lives of billions of people.
It's just one of the many stories of how people are using AI to really accelerate sort of next generation systems. So turning to AI hardware, let me say the generative AI and large language models have changed the landscape. Okay, the need for more compute is growing exponentially, whether you're talking about training or frankly whether you're talking about inference. Larger models give you better accuracy. And there's a tremendous amount of experimentation and development that's coming across in the industry. At the center of this are GPUs. GPUs are enabling generative AI. So now let me turn to our Instinct GPU roadmap. CDNA is the underlying architecture for our Instinct accelerators. It's designed specifically for AI and HPC workloads. CDNA3 is our brand new architecture that uses a new compute engine, the latest data formats, 5 and 6 nanometer process technology, and the most advanced chiplet packaging technologies. At CES earlier this year, we previewed MI300A. It's the world's first data center APU. And what we have is our CDNA3 GPU architecture with 24 high-performance Zen 4 CPU cores. And we also add with that 128 gigabytes of HBM3 memory, all in a single package. And what we have is unified memory across the CPU and GPU, which is frankly very effective, particularly for some HPC workloads. Now, this results in 8 times more performance and 5 times better efficiency compared to the MI250X accelerator that is in the largest supercomputers today. Now, MI300A has also been designed into supercomputers already, and it's slated for the 2+ exaflop El Capitan system at Lawrence Livermore National Labs. It's the most complex chip we've ever built, with more than 146 billion transistors across 13 chiplets. Now, you guys know we've led the industry with the use of chiplets in our products. And our use of chiplets in this product is actually very, very strategic. We created a family of products. So in addition to the MI300A product, with our chiplet construction, we can actually replace the 3 Zen 4 CPU chiplets with 2 additional CDNA3 chiplets to create a GPU-only version of MI300, optimized for large language models and AI. To address the larger memory requirements of large language models, we actually added an additional 64 gigabytes of HBM3 memory. So with that, I am super excited to show you, for the very first time, MI300X. Now, for those of you who are paying attention, you might see it looks very, very similar to MI300A, because basically we took 3 chiplets off and put 2 chiplets on, and we stacked more HBM3 memory. But what you see with MI300X is we truly designed this product for generative AI. It combines CDNA3 with an industry-leading 192 gigabytes of HBM3 that delivers 5.2 terabytes per second of memory bandwidth, and it has 153 billion transistors across 12 5-nanometer and 6-nanometer chiplets. So look, when you look at the world, there are many things that you need. You need great compute engines, but you also need a lot of memory for everything that's going on. So when you compare MI300X to the competition, MI300X offers 2.4 times more memory and 1.6 times more memory bandwidth. And with all of that additional memory capacity, we actually have an advantage for large language models because we can run larger models directly in memory. And what that does is, for the largest models, it actually reduces the number of GPUs you need, significantly speeding up the performance, especially for inference, as well as reducing total cost of ownership. So, of course, I want to show you the chip in action for the very first time. So let's watch MI300 in action, shall we? For this demo, we wanted to show you a large language model running real-time inference on a single GPU. We're actually going to run the recently released Falcon 40B foundational large language model, which is currently the most popular model on Hugging Face right now, featuring 40 billion parameters. So let's watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. All right, let's start. We have to give the model a prompt. So we are here in San Francisco. Let's say, write a poem about San Francisco. Here we go, the poem's coming. You can see it's responding in real time. I'm not a great poet. I don't know about you guys. The city of dreams that always keeps you yearning for more. I would say that poem's pretty good, huh? Now, look, you guys have all used generative AI already, and you've seen a number of generative AI demos in the past few months. But what I want to emphasize that's special about this demo is it's the first time a large language model of this size can be run entirely in memory on a single GPU. A single MI300X can run models up to approximately 80 billion parameters. So what does this actually mean? If you look at the industry today, you often see that, first of all, the model sizes are getting much larger, and you actually need multiple GPUs to run the latest large language models. With MI300X, you can reduce the number of GPUs for this, and as model sizes continue growing, this will become even more important. So with more memory bandwidth, and fewer GPUs needed, what this means for cloud providers as well as enterprise users is we can run more inference jobs per GPU than you could before. And what that enables is for us to deploy MI300X at scale to power next-gen LLMs with lower total cost of ownership, really making the technology much, much more accessible to the broader ecosystem. And what that also means is that not only do we believe that we have better total cost of ownership, but we've also been able to significantly reduce the amount of development time needed to deploy MI300X. Our goal with MI300X is to make it as easy to deploy as possible. And what that means is the infrastructure is also incredibly important, which is why I'm also excited to announce the AMD Instinct platform. And what we're doing with this platform is, again, we're all about open infrastructure. So what we're putting is 8 MI300Xs in the industry standard OCP infrastructure. And for customers, what that means is they can use all of this AI compute capability and memory of MI300X in an industry standard platform that drops right into their existing infrastructure with actually very minimal changes. And with this leveraging of OCP platform specification, we're actually accelerating customers' time to market and reducing overall development costs while making it really easy to deploy MI300X into their existing AI rack and server infrastructure. So I'm happy to say that MI300A began sampling to our lead HPC and AI customers earlier this quarter, and we're on track to begin sampling MI300X and the 8 GPU Instinct platform beginning in the third quarter. And in addition, we expect both of these products to ramp in production in the fourth quarter of this year. So I really look forward to sharing more details on the MI300 family when we launch later this year. Now, since launching EPYC in 2017, we have been laser focused on building the industry's best data center CPUs. EPYC is now the industry standard in the cloud, given our leadership performance and TCO across a wide range of workloads. And that momentum is just growing as we ramp our 4th-gen EPYC Genoa processors. Genoa features up to 96 high-performance 5-nanometer Zen 4 cores. It has the latest I/O that includes PCI Gen 5, 12 channels of DDR5 memory, and support for CXL. We launched Genoa actually last November, and it had leadership performance and efficiency. So let's just take a look at some of those metrics for Genoa. Starting first with the cloud, integer performance is key. We deliver up to 1.8 times more performance per watt than the industry, compared to using the industry standard spec power benchmark. And what that means is that Genoa is by far the best choice for anybody who cares about sustainability. Actually, today, the vast majority of AI workloads are actually being run on CPUs. And Genoa is also the best CPU for AI. The best way to look at AI performance is actually to look at a broad set of end-to-end workloads. And so we use the industry standard TPC-XA benchmark that actually looks at end-to-end AI performance across 10 different use cases and a host of different algorithms. And what we see in this case is EPYC is 1.9 times more performant than the competition. Now, you can see I'm tremendously excited about Genoa and all of the applications that our customers are running on Genoa. But what I did say earlier is that data center workloads are becoming increasingly more specialized, requiring optimized computing solutions across CPUs, DPUs, and of course, AI accelerators. So all of these factors actually drove the development of Bergamo. Bergamo is actually our first EPYC processor designed specifically for cloud workloads. As you guys know, I love my chips. Our chips. I am very happy to show you Bergamo. This is our new cloud-native processor, and what we have here is there's actually a new compute die. So the compute die is different from Genoa, using our triplet technology. Each of these 8 compute dies has 16 of our Zen 4 cores, and then we use the same 6-nanometer I/O die used by Genoa in the center. If you take a look at the core, the Zen 4C core is actually an enhanced version of the Zen 4 core. Zen 4C is actually optimized for the sweet spot of performance and power, and that actually is what gives us the much better density and energy efficiency. And then we optimize the physical implementation of Zen 4C for power and area, and we also redesigned the L3 cache hierarchy for greater throughput. So if you put all this together, the result is a design that has 35% smaller area, and what you have is each of the 8 compute chiplets on Bergamo contains twice the number of cores as was on Genoa. And that's how we get to 128 cores per socket. But importantly, as I said, it's fully software compatible, and it's also fully platform compatible with Genoa. And what that means for customers is they can easily deploy either Bergamo or Genoa, depending on their overall compute needs and their overall workloads. And so we really tried to leverage the overall platform investment in AMD. So let me show you some of the performance metrics on Bergamo. If you compare Bergamo to our competition's top of stack, what you'll see is just incredible performance. We're delivering up to 2.6 times more performance across a wide range of cloud-native applications, whether you're talking about web front end, or in-memory analytics, or very heavy transactional workloads. And then if you look beyond that, in terms of looking at sort of the overall density and capability, Bergamo, again, is significantly better than the competition in compute density and energy efficiency. So what we see is more than double the number of containers per server, and 2 times the energy efficiency in Java workloads. So I'm happy to say that Bergamo is shipping in volume now to our hyperscale customers. Now, to enable generative AI, you need both best-in-class hardware, but we also need a great software ecosystem. So let me now invite AMD President Victor Peng to the stage to share more about the growing software ecosystem for our AI solutions.
Thank you, Lisa. Good morning. It's really great to be here, and it's especially exciting for me, not only because now we've really put all the focus of the company under one roof, the data center GPU team, and our newly formed AI group. And I can sum up our direction and the current state of things right now and how we're enabling AI and software development with 3 words: open, proven, and ready. Now, while this is a journey, we've made really great progress in building a powerful software stack that works with the open ecosystem of models, libraries, frameworks, and tools. Realizing application performance really does require a leadership software stack optimized for the ecosystem. Let me first cover ROCm, which is the software stack we have for our Instinct data center GPUs. ROCm is a complete set of libraries, runtime, compilers, and tools needed to develop, run, and tune AI models and algorithms. A significant portion of ROCm stack is actually open. Our drivers, language runtime, tools like our debugger and profile, and our libraries are all open. ROCm also supports the AI software ecosystem, including open frameworks, models, and tools. Now, ROCm is actually in its 5th generation, and it includes a very comprehensive suite of optimizations for AI as well as high-performance computing. Now, this provides a very sound foundation for continued PyTorch and TensorFlow compliance, which enables a really rich out-of-the-box AI experience. So now let's move up the stack to frameworks, and specifically PyTorch, which is one of the most popular and growing framework. And what better person to do that than to have one of the founders of PyTorch talk about the collaboration AMD and PyTorch are doing to advance AI. So I'd like to introduce Sumit Katala to the stage to talk about PyTorch. So it's really great to see you. Thank you for coming.
Absolutely.
So can you share some of your thoughts about the AMD and PyTorch collaboration?
For sure. The PyTorch and AMD collaboration goes way back, several years back. AMD and Meta have been collaborating in various forms, and PyTorch mostly came out of Meta. It's a multi-year collaboration. We've been giving AMD a lot of feedback on many aspects of the ideal hardware and software to run AI workloads, and AMD and us have been partnering together to build the ROCm stack and a bunch of PyTorch operators and integration to robustly test the whole stack. And I'm pretty excited for the current support, especially on the Instinct accelerators that ROCm enables. And I'm pretty excited about MI300 as well. I think this is the start. I'm looking forward to how customers end up finding the maturity of the stack, but we've spent a lot of time trying to make sure it does come out right.
Yeah, we're really excited about MI300 as well as several others, so thank you for that. So how do you see the collaboration that we're doing together benefiting the developer community?
Sure. Yeah, this generally in AI workloads, one of the things we have is we have a single dominating vendor, and when you write your workloads, and you have to make them be supported by switching to a different hardware. There's a lot of work that goes into doing that. Like there's a lot of software work that developers have to do to like move your neural network workloads from one platform to another. So one of the things that we've done with AMD, with the ROCm stack and the PyTorch integration, is you don't actually have to do that much work, or almost no work in a lot of cases, to go from one platform to the other. So you might do a little bit of tuning work once you're deployed onto your AMD GPU, but it's like super seamless. And so developers, I think, are going to have a huge productivity boost as they try to switch to like the AMD backend of PyTorch versus like the TPU or like Nvidia backend. So I'm pretty excited about like the overall productivity developers would have when they're switching to the AMD backend overall. Like, and it's starting with the Instinct GPUs, and I'm hoping like you all enable it for like all of your other class of GPUs as well.
Absolutely, it's the goal to enable that capability to all the developers across all our platforms.
Yeah.
So thank you so much for the partnership. Really appreciate it.
For sure.
And look forward to more together.
Yeah.
Thank you. PyTorch 2.0 provides an open, performant, and productive option for developers to develop their latest AI inventions. And that option and that creativity and democratization, if you will, is super important. We are one of only 2 GPU platforms that is integrated with PyTorch at this level. OK, so we've covered ROCm and integration in open frameworks. That leads us to moving up to the top of the stack with AI models and algorithms. Hugging Face is the leading enabler of AI model innovation in the open source community. They offer an extremely wide range of models, including transformers that are at the heart of generative AI, but also vision models and models for all kinds of other applications and use cases. So here to talk to us more about their groundbreaking work and the partnership we have with Hugging Face is Clem Delange, CEO of Hugging Face. Please welcome Clem.
Hey, everyone.
Clem, it's great to see you. Thanks for coming. Why don't we just start off with share your thoughts about why open source matters for the growth and the proliferation of AI?
Thanks for having me. So first, it's important to remember that most progress in AI in the past 5 to 10 years has been thanks to open science and open source. Maybe we would be 50 years away from where we are today without it. Now, when we look to the future, open science and open source AI are not only a way to accelerate technology, but also to level the playing field. In the future, we want every single company to be able to train and run their ChatGPT on AMD hardware, right? And all of that allows companies to build AI themselves, right? Not just to use AI through APIs, for example. By doing so, most of the time with customized, specialized, smaller models, it makes AI faster, cheaper, and better to run. It also makes it safer for the companies, but also for the field in general, because it creates more opportunities for transparency and accountability, which fosters more ethical AI.
Yeah, that's tremendous, yeah. So just thrilled about that. So, and I'm personally thrilled that we just recently formalized our relationship. Can you share what the Hugging Face and AMD partnership is going to deliver?
Yes, we're super excited about this new partnership. So Hugging Face is lucky to have become the most used open platform for AI. Today, we have 15,000 companies using our software, and they have shared over 500,000 open models, datasets, and demos. Like some you might have heard of, like Stable Diffusion, Falcon, Bloom, Starcoder, Music Gen that has just been released by Meta a few days ago. Over 5,000 models, 5,000 new models were added just last week. I think it shows the crazy speed of the open source AI community these days. We will optimize all of that for AMD platforms, starting with Instinct GPUs. We will also include AMD hardware in our regression tests for some of our most popular libraries like transformers and our CI/CD to ensure that new models like the 5,000 that have been added last week are natively optimized for AMD platforms. It's really important that hardware doesn't become some sort of the bottleneck or gatekeeper for AI when it develops. So what we're trying to do is to extend the range of options for AI builders, both for training and inference. I'm super excited in particular about the ability of AMD to power large language models in data centers, thanks to the memory capacity and the bandwidth advantage. Ultimately, AI is becoming the default to build all tech for all industries, right? From language models that we're talking about, but also image, audio, videos, right? We're seeing more and more time series, biology, chemistry, and many, many more domains. Hopefully, this collaboration will be one step, a great step, to democratize AI even further and improve everyone's life.
That is a truly inspired vision, and which we share at AMD. We deeply believe in that, and we're so excited that we're working together with Hugging Face to make that vision a reality. Thank you so much, Clint.
Thanks, Victor.
Really appreciate it.
Thank
you. We all know that AI, the rate of innovation of this is unprecedented. The open source community is clearly a major driver of that rate and the breadth of innovation. And AMD is ready to help our customers and developers achieve the next breakthrough in AI. Thank you so much. And now I'd like to invite Lisa back to the stage. Thank you.
All right, thank you, Victor. Let me wrap things up for today. We showed you a tremendous amount of new data center and AI technologies from our expanded portfolio of leadership EPYC server processors with Genoa, Bergamo, and Genoa X, to our expanding AI software ecosystem and our next generation MI300X data center AI accelerators. It is just an incredible pace of innovation, truly exciting. But what's more than that, we really appreciate the partnership with our partners, and a very, very special thank you to our partners who are here with us today: AWS, Meta, Microsoft, Citadel, PyTorch, and Hugging Face. We truly believe in co-development, co-innovation, and partnership. It's been a great day as we take another major step forward to make AMD the data center and AI partner of choice. Thank you so much for joining us.